All right, welcome to day 2 of perpendicular lines. So, again, this is pretty much just like what happened with the parallel lines. The first day was just solving by plugging in the point, right, for the y-intercept, so you could then figure out what your specific line was going to be. Day 2, we're going to have to actually put our equation in slope-intercept form. So that's going to be actually my first step. So I'm going to write up here, put in slope-intercept intercept form. That's intercept, by the way. By putting or by getting the y all by itself. Okay, so our first step is going to be to put it in slope-intercept form, and then we would then go through all those steps that we went through yesterday. Okay, so let's look at an example. I'm going to zoom in here a little bit more so you guys can see a little bit better. Okay, so let's look at this equation. So my goal here is to get the y by itself first, right? Because I can't see the slope before I get the y by itself, and you can't get a perpendicular slope without a slope to go off of, right? So our first step is to isolate this y. Now, we treat it like a party problem, right? We would get rid of any term that's adding or subtracting first, and then we separate the number from the y. So to get rid of the x, we would just minus x to each side. Now, can you combine x and negative 16? No. So you'd be left with 4y is equal to negative x minus 16. Okay? Then to get rid of the 4, it's multiplying with the y, so you would have to divide. And when you divide every term. So cancel that there. You're going to get y is equal to, it's negative x over 4. So again, if I wasn't there, the slope would be negative 1, right? So there's an invisible 1 right there. So this fraction is negative 1 over 4. So negative 1 over 4x, and then negative 16, not that it really matters because I'm just going to get rid of this number anyway, but would be negative 4. Okay, that puts it in slope-intercept form. That y is all by itself, right? Y is all by itself. Now we're going to set up the perpendicular equation. So I'm going to move these over so I have a little bit more room here. And I'm going to set up the perpendicular equation right here. So the original equation, the original slope is negative 1 over 4. Again, to do perpendicular, you flip the fraction, change the sign, right? So it's negative 1 over 4. It's going to become positive 4 over 1, or just 4x. And then I do not know what the y-intercept is going to be. That's what I need to solve for, right? So then I write it as plus b. And then the next step is to plug in the point in for x and y. So my x-coordinate is negative 1. Again, the first number is your x, the second number is your y. So the the x is going to be negative 1, the y is going to be 1. So I'm going to replace the y with 1, and I'm going to replace the x with negative 1. And then I can easily solve for the y-intercept here, right? 4 times negative 1 is negative 4, plus b is equal to 1. And then to solve the b completely, I would add 4 to each side. And I'm going to get 5 is equal to my y-intercept. So again, the last step here, now that I have the y-intercept, is to just go ahead and plug it into that perpendicular equation. So y equals 4x plus 5. And that would be my answer. Not too bad, right? Okay, let's try another one. Let's do one of the trickier ones on the other side. So let's do number 3. Again, I'm going to try to do a tricky one, so if you guys are watching the video to completion, you are getting answers for some of the harder things. Okay, so first things first, I need to put it in slope-intercept form, right? By getting the y all by itself. So I need to get this variable all by itself. So again, it's like a party problem. I would move the x. Now again, to move the entire term, it's just still an add or subtract. I'm not going to divide unless I'm trying to separate the 5 from the x. So if I want to move the entire 5x term, I would just subtract it to the other side. Again, you cannot combine those, right? So you would get 3y is equal to negative 5x plus 24. And then to separate the number from the y, it's multiplying right now, so I would divide to every term. And you're going to get y is equal to negative 5 over 3x. And then 24 divided by 3 would be plus 8. Again, doesn't really matter. I'm going to get rid of that term anyway. Okay, now I did this so that I can then set up my perpendicular equation because I can't see the slope unless it's in slope-intercept form. So I see the slope is negative 5 over 3. So again, perpendicular, you flip the fraction and you change the sign. So since it was negative, it's going to become positive. So I'm going to get y is equal to positive 3 over 5, x, and then plus b. Okay, now this is where I plug in the point for x and y. Again, negative 2 is going to be your x-coordinate, negative 3 is going to be your y-coordinate. So to plug it in, I would replace the y with negative 3. So negative 3 is going to equal 3 over 5x, or sorry, 3 over 5 times x, which is negative 2, plus b. Then, again, I can just plug this in my calculator. 3 over 5 times negative 2 is negative 6 over 5. So negative 6 over 5 plus b is equal to negative 3. Then to move it to the other side, I would add 6 over 5 to each side. So negative 3 plus negative 6 over 5 is negative 21 over 5. So negative 21 over 5 would equal b. So then I can take that, replace the b in my perpendicular equation with what it's equal to, and I'm going to get y is equal to positive 3 over 5x minus 21 over 5. And that would be my answer. Okay? Looks scary, but really it's not. I mean, like the fraction, it can scare you, but again, most of your calculators will do that for you. It's just, again, once you've set up the perpendicular equation, it's just a matter of multiplying by whatever your x-coordinate was and then moving it to the other side to get your y-intercept. It's not as hard as it looks. All right, again, if you have any questions or concerns, email your teachers, talk to them. We are here to help you guys be as successful as you possibly can during all this stuff. So let us help you. Just let us know. Okay.